What if NASA launched a rocket directly at the sun? It sounds easy. Just point the rocket toward the sun and fly straight there. But surprisingly, reaching the sun is actually harder than leaving the solar system. Most people think the biggest challenge is the sun's extreme heat. And yes, the sun is incredibly hot. Its surface reaches around 5,500 degrees Celsius, while its core is over 15 million degrees Celsius. But heat isn't the main reason NASA can't simply fly to the sun. The real problem is speed. Right now, Earth is orbiting the sun at roughly 107,000 kilometers per hour. Everything on Earth, including you, me, and every rocket ever launched, already moves at that speed around the sun. Imagine you're riding a fast-moving carousel. If you throw a ball, the ball continues moving in the same direction because it already has momentum. The same thing happens to spacecraft. When a rocket launches from Earth, it inherits Earth's enormous orbital speed. So even if you point a spacecraft directly at the sun, it doesn't fall straight in. Instead, it keeps moving sideways around the sun. To actually reach the sun, a spacecraft must first slow down enough to cancel most of Earth's orbital speed. And that's incredibly difficult. In fact, reducing speed enough to fall into the sun requires more energy than sending a spacecraft to distant planets like Jupiter. That's why NASA uses a clever solution. Instead of flying directly toward the sun, spacecraft use gravity assists. Gravity assists involve flying close to a planet and using its gravity to change speed and direction. NASA's Parker Solar Probe, launched in 2018, uses this exact method. The spacecraft repeatedly flies near Venus. Each flyby steals a little bit of the spacecraft's orbital energy, allowing it to spiral closer and closer to the sun. This process takes years, but it's far more efficient than trying to slow down using rocket fuel alone. As Parker Solar Probe gets closer, it faces another challenge: heat. To survive, it carries a special carbon composite heat shield nearly 12 centimeters thick. The side facing the sun can reach temperatures above 1,300 degrees Celsius. Yet behind the shield, the spacecraft's instruments remain close to room temperature. This incredible technology allows scientists to study the sun closer than any spacecraft in history. So NASA can't simply fly straight to the sun because the problem isn't just heat. The real challenge is overcoming Earth's enormous speed around the sun. Sometimes, getting closer to something in space is actually harder than traveling billions of kilometers farther away. And that's exactly why reaching the sun is one of the most difficult missions ever attempted.